This is a transistor. It is perhaps the greatest thing to have ever happened to electronics and technology in general, ever. Billions of these little chips exist all around you right now. But sometimes it just isn't good enough. When you need something a little bit beefier, try this, the MOSFET. It's very similar to the transistor, except the only advantage it has for our purposes is it can handle a bigger load. So for higher watt applications, you want the MOSFET. But how do we use it? Well, the best place to learn about a chip is to look at the datasheet. Now, up at the top, we can see the symbol for our MOSFET. Now, take a look at this diode going from the source to the drain. The diode is important because it tells us which way to use our MOSFET. Current can flow this way. If we put a positive voltage at the source and have a negative one at the drain, then the current will sink from the source to the drain, through the diode, obviously. This means that our MOSFET will always be on, regardless of the control voltage we put at the gate. The whole point of a transistor is to be able to control the voltage, so you always want to put your higher voltage at the drain and the lower one at the source for a MOSFET, but we'll talk more about this later. Now, another important thing in the datasheet is the gate to source voltage. This is the theoretical maximum voltage we can put at the gate before we destroy the MOSFET. For this one, it's 20 volts. Another is the continuous drain current. Depending on the temperature, this value tells us the max amount of current this MOSFET can handle. At 25 degrees Celsius and a gate voltage of 10 volts, this value is 29 amps. Next, the breakdown voltage tells us the maximum voltage that this transistor can handle. The gate threshold value is the minimum voltage to turn the transistor into the on state. Now, a MOSFET has an internal variable resistance, so at 2 volts, this MOSFET really can't control that much current. But at 5 volts, it can control even more, and at 10 volts, it hits its maximum amount of voltage it can handle, which is 29 amps. Let's take another look at the MOSFET so we can see how to use it in an actual circuit. We already learned that we put the positive voltage at the drain and the negative at the source. Therefore, we usually connect the source to ground. So if we want to turn an LED on, for example, we connect the positive end of the LED to our supply and the negative end of the LED to the drain pin. Then we apply anywhere from 4 volts to 20 volts at the gate to turn it on. This allows current to flow from the supply through the LED, through the MOSFET, and out to ground. The pinout of the MOSFET is gate, drain, and then source. If we build the circuit, we can see that the LED is on, however, no matter what I press at the gate. This is because, though, the gate isn't grounded, so we need to add a pull-down resistor of about 10 kilo ohms to the gate. Now that we have added that, we can see that we have complete control over the MOSFET. When I press this button, the LED turns on, and when I let go of the button, the LED immediately turns off. Now, for an incorrect demonstration, we can show what happens when you connect a positive voltage to the source and a negative one to the drain. To do this, we have to move this part down and switch it with this part of the circuit. The circuit looks like this, and as you can see, the LED is always on no matter what I press on this button. Now, that pretty much wraps it up for this video, so please like this video if you liked it and subscribe to see more like this. My name is Akil Mohideen, and I will catch you guys later.